All right, Algebra 1. I broke down, I'm using graph paper for the last section of graphing. Section 8.5, graphing parabolas in intercept form. I like graph paper just because I can write neater and straighter. I don't know. I just didn't have any at home. Okay, we're going to put our name on the page, date, period. Okay. All right. So intercept form looks like this. F of x equals a, same a we've been looking at the whole time, x minus b, x minus c. And so these are the x-intercepts right here. These are going to be your x-intercepts. So that's why they call it intercept form. The a still does what it always has done. So let's look at example 1. So example 1, we're going to start with this function. F of x equals x squared minus 2x minus 3. And we're going to try and find the x-intercepts. So the way we find x-intercepts, we've done this before recently, is we factor, right? So you got to factor it to find the intercepts. So we got to factor find a pair of numbers that multiply. You guys know it's going to look like this when we factor it. It's going to be like this, right? So these two things are going to go at the front here. 1 and a 3 are going to go in the other spots. They got to multiply to get negative 3. So one's got to be positive, one's got to be negative. They got to add up to negative 2. So the 3's got to be negative and the 1's got to be positive. I'm not showing as much work as usual. So this is the factored form. So to find the x-intercepts, also we call the x-intercepts zeros. We also call them roots. To find the x-intercepts, we use this idea called the zero product property, where it says make the y value to 0 or the fx value to 0. So we plug a 0 in. And anytime you want to find the y-intercepts, you said the x-intercept set y to 0. And so we set it to 0, and then we set each of these equal to 0 on their own. And then we solve for each of them, and they each give an answer. So we get these are our x-intercepts or roots. And we can use those to actually make our graph. So I'm going to do a graph over here, and this is where the graph paper really comes in. I don't have to draw all those lines. And looks just so much better. The arrows on the ends of your axes, label your axes. So these are x-intercepts. So they're on the x-axis plus y 0. So we have one right here at -1, and we have one right here at 3. Okay? Now, we're going to answer a lot of the same questions we've been answering. So here's the thing. The axis is symmetry and the vertex. We usually want those. So the vertex and axis of symmetry are halfway between the intercepts. Okay, halfway between. It kind of makes sense because we know that these graphs, they have 2 equal halves, right? I mean, you could see it right here. You could probably count like, oh, it's going to be like right here. But the way to do it, if you don't have a picture, is say, okay, well, it's exactly halfway between. So what we do is to find a number halfway between 2 numbers is you add them up and you divide by 2. Same thing as finding the average of 2 things. You add them up, divide by 2. So -1 plus 3 is 2, divided by 2 is 1. So your axis of symmetry, AOS, is x equals 1. And that's a vertical line that goes through positive 1. So we draw a dashed line, arrows on the ends, label it AOS equals 1. Okay? Now, by the way we used to do to find the vertex is we use this formula x equals negative b over 2a. But we don't have b or 2a, so we just average it. Okay, we're not using that this time. But then what we did before when we had this is we plugged it back into the function. So I'm going to plug this back into our function up here at the beginning. Now, if you want, you could rewrite it down here so that now it could be this version or it could even be the factored version. I think the factored version might be a little easier. Either one, it'll work the same way. But I'm going to plug it into that one. I'm going to put a 1 in for every x. Okay, and then order of operations, PEMDAS, parentheses. We got to do the stuff inside the parentheses first. That's a 2. That's a negative 2. And 2 times negative 2 is negative 4. So your vertex is at 1, negative 4. Vertex is at 1, negative 4. So 1, negative 4. It should be right on top of the axis symmetry. So there's a vertex, 1, negative 4. Now, if necessary, if you feel like you don't have that good of a graph, usually we would try and find 5 points. We got 3 points now, but I don't know. I feel like it's probably good enough. If necessary, plug in another x, like make the little table, okay, if you need to. But I think we could draw a pretty good parabola with these 3 points. Right, nice smooth curve, arrows on the ends. There's no sharp corner here. It's a nice smooth curve. So that looks pretty good. So I'm going to skip that this time. The domain, of course, is all real numbers. The shortcut for that is you can write like that. Range. That's fine. You could write it like that, but you better know what it means. The range is all the y values. So the y's start at the bottom here. This is the minimum, the lowest point in the graph, and they go up. So y is greater than or equal to negative 4. So that's your range. And then we could answer the question too. Is it a minimum or maximum? And so this is the lowest point in the graph, so it's a minimum. So that's what we're doing. Just a lot of the same kind of stuff, but a little different approach. So let's do another example like that. So example 2. And this is going to be our function. fx equals negative 1/2 parentheses x minus 3 x plus 1. Now what's different about this one compared to the last one? It's already factored, which is nice. We don't have to do that. It's ready to go. We know right here that opens down, right? And that's 1/2 shrunk by 1/2, factor 1/2. But let's find the X-Intercepts or zeros. And this time we can jump right into that. We set the y value equal to 0. It's already factored. So we set each factor equal to 0. You could set this equal to 0, negative 1/2 equals 0. That just doesn't make sense. It doesn't give you an answer. If there was an x up there, you get an answer. That would be a different kind of shape. So we solve for x. Get x by itself. These are our X-Intercepts. Okay, cool. So now we're going to find the axis of symmetry and vertex, and they're exactly halfway. Let me go ahead and start my graph, though. Let's go ahead and start a graph. Okay, so positive 3, negative 1. Those are our intercepts. Okay, so axis symmetry, it's going to be x equals, we got to add those up. 3 plus negative 1 over 2. So that's going to be 2 over 2. That's going to be 1. So the axis of symmetry is x equals 1. Which makes sense on the graph. X equals 1 would be a line that cuts it exactly in half. Axis of symmetry always cuts everything exactly in half. AOS, x equals 1. The vertex is on that line, so we use that, plug it back into the original function. For all the x's to find the y that goes with it. So it's going to be negative 1/2. 1 minus 3 is negative 2. 1 plus 1 is 2. Negative 2 times 2 is negative 4. 1/2 times negative 4 is positive 2. So the vertex is at 1, 2. 1, 2. Now, if necessary, we would plug in another x. But I think we can figure this out. Now, first of all, if you just connect the dots, it should look like it's going down, which we know already it should go down. Right? And it kind of looks a little shorter, fatter. Right? This is a maximum as the highest point. Okay, so I skipped that part. Go into the domain, which is all reals. Range is all the y values. Well, they're all less than the max. They're less than or equal to 2. Maximum or minimum. It's maximum. Okay. So that's how we're doing it. Okay. I got 2 more quicker examples. These ones we're not going to graph. Okay. So they'll go a little faster. So example 3. The directions will say find the X-Intercept axis of symmetry and vertex. And they'll give you a function. Now, it doesn't always have to be y, fx. It could be y. Negative 5, x plus 7, x minus 5. So this one's factored again. We're pretty much doing what we just did on the last problems, but we're not going to graph it. Okay? We're not going to graph it. So to find the x-intercepts, you set the y equal to 0. Right? And then you set each of the factors equal to 0 on its own. Same one. If it wasn't factored, you'd need to factor it first. But this one's already in intercept form, so that kind of makes it easy to find the intercepts because it's already in intercept form. So these are your x-intercepts. Okay. The axis symmetry, AOS, is going to be exactly halfway between these. So we just add them up, negative 7 plus 5, and divide by 2. Negative 7 plus 5 is negative 2. Divided by 2 is negative 1. So the AOS is x equals -1. Should have an x because it's a vertical line. And then the vertex, well, this is part of the vertex, but now we need the y value. So we're going to plug this back into the original function up here. -5, -1 plus 7, -1 minus 5. And we're going to do the work. So -5, -1 plus 7 is 6. -1 minus 5 is -6. -5 times 6 is -30. 30 times 6, well, 3 times 6 is 18. And you add a 0, and negative times a negative is positive. So that's a big number. The vertex is -1, 180. So you should be glad you didn't graph this one. That'd be a huge graph. Okay? Okay, last one. Example 4. So this one, we're going to actually write the equation in standard form, which is the first form we learned about with the parabola. Standard form if the X-intercepts are 1 and 9. So they're giving you the X-intercepts. Okay? So first of all, standard form looks like this. Y equals ax squared plus bx plus c. That's standard form. But since we have the intercepts, we want to use intercept form. So intercept form, which is what we've been focusing on today, intercept form, and it might be good to just write this down next to your work, is fx equals a x minus b x minus c as intercept form. And we have the x-intercept, so that could be one of them right here, and that could be the other one. It doesn't even matter which one you put. Now, the thing we don't know is the a value. So, I mean, it really could be any kind of a value with these x-intercepts. So we're going to make it easy and just go with a equals 1. Okay, so we have everything we need, so we just need to plug these in. So we're going to plug a 1 in for a. We're going to plug in a 1 in for that x-intercept, a 9 in for that x-intercept. And that's the equation for the parabola in intercept form, but we want standard form. So we need to FOIL it. All right, first, the 1 can go away. If there wasn't a 1, then we would have to do all this and then distribute the 1. First, x times x is x squared. Outer, inner, last. Right? And then you could combine the middle terms, combine the like terms. -9x, -1x is -10x together. And there you go. You have standard form. Okay. Today's classwork assignment is monitoring progress. Page 451, problems 1 through 12 all. If you do it in the student dynamic, these are at the bottom of the pages in section 8.5. At the bottom of each page during the section, they have a couple problems. If you do it on the student dynamic ebook online, there's little blue arrow buttons, and you can press those, and it'll show you video exactly how to do the problem, just to make sure you know how to do it. So there you go. Get it done.